Percents, decimals, fractions, these three quantities are all interrelated and can be rewritten in various forms of one another. And percents is something we use every day. So let's take a closer look at percents. Percents can be written as the rate out of 100. So 23% is 23 over 100, or 0.23, or 23 hundredths. We look at this then as the part over the whole, where 23 would be our part, 100 would be our whole, and we end up with our percent. Part over whole equals percent is a formula we can use, but we can rewrite this in a couple different ways. We can also look at this as the part equals the whole times the percentage. We could also look at this as the part divided by percent equals the whole. All of these can be manipulated from this original equation of part divided by whole equals percent. Percent problems that have one step are typically in one of three forms, where we look at 20 here being the part is 10% of 200 or the whole. So 20 our part equals percent times whole. So type 1 would be where our part is unknown. What is 23% of 80? We don't know what is, that part. So we could say that that is x equals 23% of 80, which we find out to be 18.4. Another way to write these percent problems is where we don't know the percent. 45 is what percent of 200? We could say that that is 45 equals, we don't know the percent, the whole is 200, times some percent, we can call that P. We can also remember that percent is part over whole, so we can write this as 45 divided by 200 equals our percentage, or our percentage is 22.5%. Sometimes the whole is unknown. 25 is 42% of what number? We can write this as 25 equals 42%. I'm going to write that as a decimal. Of what number? We don't know that number, so we can call that a variable y. Or I can remember that the part divided by percent is the whole. So 25 divided by 42% is our whole that we don't know y, which we find out to be approximately, again rounding to the nearest tenth, 59.5. Where do we see percents? Well, we often see percent markdowns. For example, we have a television that costs $350 after a 20% discount. What if we wanted to find the price of the television before the discount? Well, we don't know this price, this original amount. So we'll call this original amount X. We're subtracting from X our discounted amount. We know that we took a 20% discount, so that would be 20% of our original price, X, equals this new sales price of $350. Well, X minus 20% X would be 80%. We actually paid 80% of our original price. So we can take this original price or we can find this original price by taking our sales price of $350 and dividing that by 80%. And find out that the television originally cost $437.50. Another usage of percents often talks about change. The price of gasoline rose 4%. General Motors sales rose 12% for the month. Traffic accidents saw an 8% decrease. These percent changes are often found in the news. But again, how do we calculate this? A percent increase or a percent decrease can be modeled through the formula of the amount of increased divided by the original amount times 100 to give us a percentage. So Ellie is a tutor for the mathematics department. Last year she made $8.50 per hour. This year her hourly wage is increased to $10. And Ellie wants to know what is her percent increase. So we look at the amount of increase. The amount of increase would say she now is at $10, but we have to take away last year's salary of $8.50 to see her amount of increase was $1.50. We will take this $1.50 and divide it by the original amount, which was her original wage of $8.50. We'll make sure to multiply this by 100 to get a percentage, and we can see that Ellie's percent increase was 17.6.